Hello, my dear warriors. Welcome aboard. This is your Captain Shreyas, and I know you guys were waiting for quite some time for the relative motion chapter. And here I am bringing you both one dimension and two dimension relative motion, where we'll be starting off with one dimension relative concept, approach, separation, chasing questions, then going to two dimensional problems where we find the shortest distance and of approach kind of questions. Then we will be going to riverboat or swimmer problems, and then finally to the rain problems where you know how to hold the umbrella. All right. So that is what we are going to do in this particular class. This is your Captain Shreyas. Hello, hello, hello. Hello, Dinesh, Pavneet, Sudarshan, Mark, Paul, Dinesh, Madhumati, Philo, Mukunda. Good morning, guys. Good morning. I'll be conducting motion in 2D also. Don't worry. Motion in 2D also will happen. Okay. Don't worry. We'll just do this relative motion part. Yes. And let me also tell you, my dear students, we are doing two lectures per day now. I mean, it's really too, not too many. I mean, too much of effort, I would say, that we are putting in for all of you. So I want your regular attendance over here, not just in RNA series, but also in NCRT series. So if you are not aware of any one of them, make sure you are watching all the classes because we are trying to cover as much topics as possible in the less amount of time that we have over here. Okay, so quickly show your support for you guys by liking the video and subscribing to the Vedantu NEET English channel. As only your subscription and your love towards the channel helps us, motivates us to conduct more classes, because whatever we are doing is for you by bringing in that quality content, putting in that extra hard work for all of you. So let's start with the relative motion in one dimension first. See, okay, let me tell you, imagine there was a Pandu. Okay, this is our Pandu. And there is a Champa, and there is a beautiful Champa over here. This Champa goes to the college. Pandu is just standing and every day looks at that Champa going over here with a speed of 10 meters per second. With a speed of 10 meters per second. So I will say that the velocity of Champa with respect to Pandu, meaning Pandu is the observer, Champa is the object or the particle or that thing which is moving. So Champa is being observed by Pandu. That is how you write it in physics. C is the one which is observed. P is the one who is observing. The first one is the object being observed. The second number that you write is always the observer, the point of view, the perspective. So the velocity of Champa with respect to Pandu, I will say it is 10 meters per second. I will say it is basically 10 meters per second towards, let's say, the east direction. This is how you mention something called as velocity of something with respect to something. And velocities are always relative. I'll tell you why. There was another Pandu one day, and this Pandu was on his bike, or maybe he was also walking towards the same college. This is another Pandu. So Pandu has now a competition. This Pandu is walking with Champa every day with the speed of 10 meters per second. So this first part which we just did, velocity of Champa with respect to Pandu, I said was 10 meters per second towards the east. That was with respect to this Pandu number 1, was with respect to Pandu number 1. But now since we have Pandu number 2, if I ask you what is the velocity of Champa with respect to this Pandu number 2, because Pandu and Champa are moving together, when Pandu looks towards his left side or whatever towards his side, he will always see that Champa with him. He will see the Champa is at rest. So he will find that Champa at rest. Interesting, isn't it? He'll find the Champa at rest. Agree or disagree? Imagine now comes more competition, and then you have another Pandu over here who is going on a bike. Who is going on a bike? There is a Pandu over here, and he is going on a bike with a speed of 20 meters per second, like this. 20 meters per second, like this. In 1 second, Champa goes 10 meters. In 1 second, this Pandu goes 20 meters. So for this Pandu, Champa has actually gone behind in that 1 second. Do you guys agree with it? So actually, for this Pandu, this Champa has gone behind by how much? 10 meters. So for this particular Pandu, the velocity of Champa for this Pandu number 3 will be 10 meters per second, but towards the west direction. Isn't it crazy, guys? How your observer decides the relative motion. Observer decides the relative velocity and the relative motion. So this concept of velocity, acceleration, displacement, all these concepts are actually relative to the observer. Usually, our observer used to be standing silently on the ground. Pavam guy, jobless fellow. Train is going. Any physics problem? Train was going at 50 meters per second. Pavam observer observing the train. A bicyclist was accelerating at 2 meters per second square. Nicely is observing, standing. Jobless fellow. Whole day he stands like this over there. A man displaces by 5 meters towards the east. Okay, he will see it quietly. But now you can have observers on a moving train, on a falling apple, on an accelerated bus, on a braking scooter, or on a cycle which is moving at certain speed, or some other planet, and you will see things will change, and sometimes it will in fact become easier to analyze the problems. It will sometimes becomes easier to analyze the problems. Correct. Now you might think, sir, velocity is relative, sir. Acceleration is relative, sir. Displacement is relative, sir. Sir, is force relative? Hmm. Sir, is pressure relative? Is the relative concept applicable everywhere? Answer is no. Don't just chumma say, sir, this is also relative, that is also relative. Not everything is relative. Like when I say, I apply 5 Newton force. Sir, I was standing, I did not do homework. So teacher slapped me, sir, thap, 5 Newton force I got. Sir, 5 Newton force, sir, is it relative to the teacher or to the me, sir, or to the champa, sir? It is absolute. So 5 Newton means 5 Newton. You cannot say with respect to that person standing behind, sir, with respect to the backbencher, he finds this slap is nothing, sir. I have got even tighter slaps, 100 Newton. So 5 Newton is nothing. So you cannot say slap is relative. No, slap force is basically absolute. So forces and many things in physics are absolute. Certain things like velocity, acceleration, displacements are relative. Time is also not relative in our normal physics, but in Einstein physics, it is relative. Let's not go there because we are studying NEET physics, not Einstein physics. Okay. Keeping that in mind, let's do some more concepts of relative motion in 1D. See, I'll tell you one simple trick to find out. I'll tell you one simple trick to find out, what is the velocity of one thing with respect to the other thing. See, there are two things. If you're trying to find speed or are you trying to find vector? When you're trying to find speed, it is actually very easy. So say, for example, you're trying to find relative speed. Relative speed. So let's take some scenarios. We have Pandu, who is going like this, who is following a champa, going like this. Let's say this is V1, let's say this is V2. Then what happens is our Pandu gets very angry. I'm following Champa every day. Champa is not giving me bhav only. No, no interest. So Pandu gets angry. Why is this girl throwing attitude? So Pandu decides, to hell with you. I am just going this way with some speed. Champa decides, why is this Pandu not following me today? So Champa feels that I have done something wrong. I want attention. So Champa now starts running towards Pandu. Champa starts running towards Pandu. And then Pandu is like, all these days I was running behind you. You did not even see me. Now you are coming behind me. So then they understand that they love each other. So the next day, when Pandu sees Champa, Pandu runs towards this particular Champa, like so, with some speed, this way. But as in every relationship, Not every day is a bed of roses. So they fight one day. They have a small breakup. So this Pandu is very angry with this Champa. So this Pandu goes over here, and this Champa, which is over here, right? This Champa goes here because they fought with each other. It's a small part of their big story. Obviously, some other day again they will, be back together. All right. So in certain cases, you might see that the person is chasing or approaching each other. In certain cases, you might be seeing they are going either towards or away from each other. Like this one and this one is the case of chasing. This one and this one is the case where both are, crossing each other. They are crossing each other. They are crossing. They have crossed and they are going, opposite to each other. So this is in the same direction, like you can see over here. Let me just put it over here. The first one is where you are basically chasing. These are kind of chasing questions, or basically in the same direction, or basically in the same direction. If you see over here, if you see here, these are kind of crossing questions, or I would say you are moving in the opposite directions. So when you measure the relative speed of one person with respect to the other person, when you measure the relative speed of Champa with respect to Pandu, Pandu with respect to Champa, speed, not velocity. Velocity and speed, what is the difference? One is a vector, one is a scalar. One has a sign, one does not have sign. You always take the mod value. Speed is the scalar, where you only are interested in the magnitude. Isn't that right? Everyone with me? Yep. Awesome. So my dear students, in such cases, what you do is basically when you try to find the relative speed. See, imagine Champa is going with 5 meters per second, Pandu is going with 7 meters per second. Champa in 1 second traveled 5, Pandu traveled 7. So relatively, they have traveled only 2. Just think about it. Champa traveled 5, Pandu traveled 7. So relative to each other, they have only traveled 2 meters. So basically, you subtract their magnitudes. So speed, relative speed is modulus of the bigger minus the smaller one. Whichever is bigger, you put first. Whichever is smaller, you put next. Is that clear? Yep. You subtract them. And if it is opposite, just imagine Champa moved 5 meters in 1 second, Pandu moved 7 meters in that 1 second. So for Champa, Pandu has moved actually 5 plus 7, which is 12 meters. I move towards you by 2, you move towards me by some. So our relative will add. You will come faster because you are going opposite. So you will add them. So hence the relative speeds will basically add. And when you say add, it means it will be V1 plus V2. As simple as that. So you add their magnitudes. Is that right? Now the simple way to remember it is opposite. What is the symbol for opposite, guys? What is the symbol for opposite? What is the symbol for opposite? This one, right? Turn this opposite symbol, it will become plus. Turn this opposite symbol, it will become plus. See that plus sign over here? Yep, very good. Same, same means equal to. Merge these two together, it will become one dash over here, which is like minus sign. I'm going in the same direction, equal to symbol, same direction, chasing. Merge them together, it becomes minus, which is exactly this symbol. Now you will never forget yes or no. Got it, everyone? With me on this? You will never ever get confused. Never ever get confused. Perfect. But when it comes to relative velocity or relative displacement or relative acceleration, then there is a simple formula I'll tell you. So whenever it is relative velocity, relative vector quantity, okay, then always it involves vector subtraction. Vector subtraction. The formula looks something like this. Oops. When I write V12, it means velocity of 1 with respect to 2. In this case, you will notice that this number 2 is nothing but our observer, or I would say the frame of reference, and this number 1 is being observed, or it is the object, or it is the particle. This is how the nomenclature goes. V12, it will be velocity. If it is A12, it will be acceleration. If it is S12, it will be displacement. So this symbol can change. It would be velocity, displacement, acceleration. So it is of 1 with respect to 2. So this means that our observer was 2 and the one being observed was labeled 1. That is what it means. This is frame of reference, point of view, perspective, and this is being observed. Is that right? So what is the formula for that? The formula for that is as follows. V12 is nothing but V1 vector minus V2 vector. Very, very important formula, my dear warriors. V12 is V1 vector minus V2 vector. This is how it goes. Now, if you have any other thing, say for example, if you say, sir, if V12 you are saying is V1 vector minus V2 vector. Sir, what about A12, sir? Acceleration of 1 with respect to 2. It will be A1 minus A2. If it is displacement of 1 with respect to 2, then it will be S1 minus S2. So then, what about V21? What about V21? It will be V2 minus V1. What about A21? A21, it will be nothing but A2 minus A1. What about S21? It will be nothing but S2 minus S1. In fact, if you notice, these two are exactly negative of each other. So, strictly speaking, V21's negative is actually V12. Same thing applies for A12 also. Same thing also applies for S12 also. They are magnitude wise equal, but direction wise opposite. They are opposite. You subtract the displacements, you get relative displacement. Subtract the accelerations, you get relative acceleration. Subtract the velocities, you get relative velocity. So this is negative of each other. So which also means that if one is the observer, and that person sees second object going like this relative to him, then when 2 becomes the observer, he will see object number 1 exactly going in the opposite direction but with the same magnitude. This is what it means. Now I know some of you might be also wondering, see, what is this V1, V2, A1, A2, S1, S2? What is it with respect to? So keep this in mind now. When you do not have the second subscript, say for example, I tell V1, the real question arises, what is it with respect to? So this actually means velocity of 1 with respect to the ground frame. So it is velocity of 1 with respect to basically the ground frame. So whenever the second subscript is not mentioned, it means the observer is the earth. So earth can be represented by putting these lines. So this is your ground frame where your trees are there, buildings are there, etc. Okay, buildings are there, etc. So that is basically the ground frame, and you are observing something with respect to that earth which is in motion. Is that absolutely clear, my dear warriors? Is this absolutely clear, my dear warriors? Yep, perfect. So let me show you certain examples also based out of this, and that will make things very, very clear. Say for example, I tell you, listen, there is something which is going over here by 2 meters per second, and another thing which is going at the rate of 5 meters per second. This is object 1, this is object 2. If you ask me, what is the velocity of 1 with respect to 2? By definition, it is v1 minus v2. What is v1? v1 is 2 I cap. Remember, it's vector velocity. What is v2? It is basically 5 I cap. So 2 minus 5 is basically minus 3 I cap. This minus sign indicates that if if 2 is the observer, if 2 is the observer and looks at 1 that person will see that object going at a speed of 3 meters per second in the negative I cap direction. That is what it means. That is what it means. Similarly, if one decides to find V21, we know it will be negative of V12. So it will be just negative of 3 I cap, which is basically 3 I cap, which means if now one becomes the observer and then looks at 2, that person will see him going at a speed of 3 meters per second in the I cap, which is the positive x-axis direction. The same thing can be also applied for even accelerations. Let me show you some examples of that as well. Let me show you the examples of that as well. Imagine some ball is falling because of some air resistance at 8 meters per second square, and there is a rocket which is flying up, okay, maybe at 2 meters per second square, okay, maybe like this. So this is your rocket, this is your ball, and somebody asks you what is the, assuming, yeah, what is the acceleration of the rocket with respect to the ball. Here is what you will do. First symbol first, then comes the next symbol. What is the acceleration of the rocket? It is 2 j cap. What is the acceleration of the ball? It is basically minus 8 j cap. Minus minus will become plus. So 2 plus 8 will become basically 10. So it will be 10 j cap meters per second square, which means that if the ball is taken as our frame of reference, then the rocket will be seen to go up at the rate of 10 meters per second square. The rocket will be seen to go up with a speed of 10 meters per second square. Also, you should realize that whenever you solve some chasing problems, crossing problems, etc., say for example, you have a truck and maybe there is some car, or some bus over here, and that bus has to overtake this particular truck, right? So you usually do such questions with a concept of relative motion. Maybe you can make the truck itself as the frame of reference. Maybe you can make the truck itself as the point of view or the frame of reference. You will see the bus or that car going like this. So when the front of that bus is directly behind the truck, that's when you start overtaking the truck. And when the behind of the bus just crosses the front of the truck, you have completed the overtake. So if you notice, you have not only traveled the length of the truck, but you have also traveled the length of the bus. So this is the total relative displacement that you have done. Relative displacement of the bus with respect to that particular truck. Do you guys agree with it? So if the truck was the observer, the truck will see the front of the bus has gone till here, so covered its own length plus the bus's length. I hope that makes sense to you. And you can definitely use relative displacement is nothing but relative velocity multiplied by the time for such questions. Relative velocity multiplied by time. Distance is speed into time, velocity into time is displacement. Also, you will notice, let's say two things crossing against each other. Maybe there is a train over here going like this, another train going in the opposite direction. So whenever you get such problems, what you do, you make one of them as the frame of reference. You make one of them as your frame of reference, point of view. So everything is being observed in respect to that. So you will see that the other train, which is over here, will now come with a relative velocity, The crossing starts right over here till the time the back of the other train has reached the back of this particular train right over here. So the engines meet, then they cross. So this train will reach here. So their backs are at the same point. Then the complete journey is over. So if you notice from here to here, this is the relative displacement, or basically the length of this train plus the length of this train. So that becomes your relative displacement. So again, you can use relative displacement is relative velocity multiplied by the time taken to cross. So all these things you are allowed to do. So in this particular problem where, trains are moving in the opposite direction or things are going in the opposite direction, truck is crossing the bus. So, what you do is generally make one of them as the observer. Anyone, doesn't matter. So if you make this as the observer, that means this is at rest. The other thing will move with relative velocity. Now it becomes a simpler problem. It's just that you are standing and the other thing is coming at a higher speed or a different speed. That will be the relative speed. So if you want to find the time to cross, meaning the engine of the train is meeting the engine of this train, or the fronts are meeting each other, and then the engine will reach here when the backs are just on the same line. So you have not only traveled the length of this particular vehicle, but also the length of this vehicle. So this is the total relative displacement. Does that make sense to you? Is that okay, Pavni? Yes, everyone with me? Awesome. Okay, so these kind of questions are solved in this particular manner. You might also find certain questions. Where there is probably a bus or something, where there is a bus or something. Okay, and this bus is in motion. Okay, this bus is in motion, and then there is another person behind at some distance running towards the bus with some acceleration, etc. So when will they catch? Right? Those kind of questions. So what you do again is convert this entire problem relative to one of them, either the bus or the person. So if you make the bus as the frame of reference, that is your point of view or frame of reference, then you will see that this person is standing behind somewhere over here and moving with some velocity, with some acceleration, and will have to move this much distance to catch the bus. This much distance to basically catch the bus. This is now relative motion concept. And this is your relative displacement over here. You might even have some relative acceleration also if the bus or the person is accelerating. So everything you make with respect to something. Make one person stationary and then observe, because that's what you have been doing normally. Okay, that other person is coming with this much velocity. Okay, this much acceleration, this much displacement. So then you are allowed to use, S is ut plus half at square, V is ut, u plus at, and all of that. So all these equations are allowed, guys. All these equations are basically allowed. So S is ut plus half at square, V square is u square plus 2as. But keep this in mind. This velocity will be relative. Acceleration will be relative. Displacement will be relative. U will be relative. This acceleration will be relative. This V will be relative. This will be also relative. This will be relative, and this will be also relative. All these things will be relative. All these things will be relative. All these equations are valid. So kinematic equations are valid. So kinematic equations are valid if obviously the relative acceleration is going to be a constant. If the relative acceleration is going to be a constant. Cool. Now, shall we do some questions on this? Now, shall we do some questions on this? Now that you understood what this concept is all about. Okay, so let's do some questions. Here is the question coming up on your screen. Two objects are moving towards each other with velocity 10 and 12. As shown, find the velocity of A with respect to B and B with respect to A. Okay, let's try to do these questions, guys. Starting off with the first question now. Velocity of A with respect to B is VA minus VB. VA, this is A, that is B, is nothing but 10 I cap. VB is nothing but minus 10 I cap. Okay, 10 and 12. I think diagram has something misprinted. So I think this was 12. I think they misprinted it. Okay, so 12. Alrighty. So this will become minus 12 I cap. Why minus 12? Because it is left side. So minus minus becomes plus, so it will become 22 I cap. So that is velocity of A with respect to B. If somebody asks you the next part, find the velocity of B with respect to A without knowing this, it will be VB minus VA. VB is nothing but minus 12 I cap minus VA is basically 10 I cap. So minus 12 minus 10 will become minus 22 I cap. So that is the answer, plus 22 and minus 22. Yes, that is correct. Got it, my dear warriors? Everyone, just using vectors, nothing more, nothing less. Just using vectors. Simple. Let's do the next. Let's do the next. A particle is moving with some speed towards the right. Another particle is moving at another speed towards the right. Find the velocity of approach. Obviously, they are chasing. Same direction means they are chasing, right? Okay. So this is a question of chasing. And whenever it is chasing questions, basically it is in the same direction. The relative speed, the relative speed will be nothing but V1 minus V2 mod minus same collapse minus sign, right? Which is bigger, which is smaller? 20 is bigger, 5 is smaller, so it will be 15 meters per second. So basically every second distance reduces between them by how much? By how much? 15 meters. That means approach, the relative approach is nothing but 15 meters per second. So this is what we have got. This is what it means. Every second, B and A, whatever the distance is, if it is 100, it will be reduced by 15. It will become 85. That 85 will then become 70. That 70 will then become 55. Every second, that's what the distance reduces. Is that clear? Everyone with me? Awesome. Moving on to the next question. A and B, these are Tatva questions, by the way. And there are many such questions in Tatva which helps you build the conceptual understanding, Okay, so you can do that. And by the way, I have some amazing surprise for all of you. Do you see what is there in my hand? You see what is there in my hand? These are like small books, and I will tell you about this. I mean, just look at this. This is like your pocket. This will fit in your pocket. These are like your quick revision cards, which I've just got from Vedantu, and I'll be telling you more about it in the due, course of time. This has some amazing flashcards, like pocket size cards, and this will help you in your revision. Say you open up anything over here, let's say something over here. Yeah, perfect. These are like pocket size cards with small revision concepts, flashcards. Exactly. So yeah, I will let you know more about it in the due course of time. Is there for all the subjects? Same thing for even chemistry. Even there are some different kinds of revision booklet even for like practical chemistry. So you have this nice little cute little booklet. Aram se, you're traveling, you're sitting somewhere, Even in the toilet you are sitting, aram se take this book in the toilet and open it up. Don't worry, it is having some plastic coating. Water will not damage it so much. Okay. So next question. A and B are thrown vertically up with a velocity 5 and 10 respectively meters per second. Find the separation after 1 second. Find the separation between them after 1 second. What do you do? Let's do it purely by relative motion concept. So if you ask me, what is the initial velocity of A with respect to B, which is UA minus UB, it will be nothing but UA is nothing but 5 minus UB is basically 10. Everything is in the upward direction, that's why it's positive, so it is minus 5 meters per second. That is initial velocity of A with respect to B. If you ask me what is the acceleration of A with respect to B, acceleration is always downward, so minus 10 j cap. B also has same acceleration. Every object on Earth has the same acceleration due to gravity. Yes, Dinesh, toppers study even in the toilet, even in the bathroom. I have seen some people in the bathroom, they have drawn designs of organic chemistry on the tiles. Their mother scolded them, but they told, listen, I will become doctor and I will give you bigger toilet. I'll build bigger house for you. The mother said, okay. So the kid kept on drawing on the walls. So that is the excuse you can give. Okay. So what is this? Oh my God, this is a big fat zero. 0 meters per second square. Find the separation between them after 1 second. So if I use S relative is equal to U relative, okay, into time plus half A relative into T square. This whole term is a big fat zero because A relative came out to be 0. U relative is minus 5 time 1 second. So it will be minus 5 meters. But they have just asked the separation. So separation will be nothing but modulus of negative 5. So it will be 5 meters. I'm just interested in the modulus. Answer is 5 meters. Okay, I'm just interested in the mod value. Is that okay? Yeah. Very good. Excellent. Excellent. Let's move to the next question on your screen. Two trains, 50 meters, opposite speeds given PMT 1999. What does it tell you? PYQ? Okay, opposite directions means opposite. Turn it plus. So relative speed will be plus. What are the speeds? 10, 15. What will it become? 25. What did I tell you? Relative distance is relative speed multiplied by the time to cross, catch, chase, whatever. Distance, what will it be? This train and this train, both the distances should be added. Guys, it will be 50 plus 50. Remember, I have been telling you this just some time back, right over here. Right over here. This distance plus this distance is the total distance, correct? So hence, what will it be? Where did it go? Yeah. So 100 is equal to 25 multiplied by time. Time is 4. Is it there? Option number 2. Yes. How many of you got option number 2? Let me see. Very good. Isn't it simple the way I taught you guys now? It becomes very easy. Right? Awesome. Let's go to the next question coming up on your screen. Thief's car is moving with a speed of 10. A police van is chasing this cart with a speed of 5, fires a bullet with a muzzle velocity of 72. Oh, find the speed with which the bullet hits the car. Okay, let's visualize. A police van chasing at 5 meters per second. So police van is slower for some reason, moving at 5 meters per second, muzzle velocity of 72. What is muzzle velocity of 72? Okay, 72, first of all, convert it into meters per second by multiplying it by 5 by 18. Sorry, 72 is divisible by 18. 4 times 4 5s are 20. So 20 meters per second. That means that bullet which is there, it will have an additional speed of 20 meters per second. So the actual speed of the bullet, because this 20 was with respect to the car, will be actually 25 meters per second. So muzzle velocity means with respect to the firing barrel or that gun or that cannon. So additionally, the gun's velocity will also add up. In this case, the gun and the bullet were traveling the same direction, so they will add up to become 25. Is that right? Yes. Lack of petrol in the police car. Probably Sony. Or maybe there were a lot of police people in that car. Okay. Thief moving at 10 meters per second. Thief, obviously, thief will be going in the same direction. Obviously, thief can't be going in the opposite direction. People ask me such doubts. Sir, how do you know thief is going in this direction? See, the thief will assume that the thief is smart. Otherwise, what kind of thief will you become? You're moving opposite to the police. You want to be caught. Hey, come here. I'll catch you. No. So thief is going in this direction with what speed? 20 meters per second. Now, obviously, this speed will be more than this, or else how will the bullet hit the thief? Imagine police fires that bullet, and the bullet speed is still lower than the thief speed. That will be bad. What is the thief speed? How much was it? 10. Oh, it's very less. Okay, fine. 10 meters per second. So what is the relative speed? What is the relative speed? Same direction, that means subtract. So it will be 25 minus 10, which is basically 15 meters per second. Perfect. How far is the thief? A policeman is to find the speed with which the bullet. Oh, that's it. We just have to find the speed. That's it. You got it. We don't have to find the time. We just have to find with what speed will the bullet hit the car. It will hit it with a relative speed of 15 meters per second. Perfect. We got it. Okay, because the car is also moving. So the bullet will strike with a relative speed. Bullet and car both are moving. So relative speed. Got it? Awesome. Awesome. Blossom. Moving on. Next question on your screen. NEET 2009. A bus is moving with a speed of 10 on a straight road. A scooterist wishes to overtake the bus in 100. Bus is at a distance of 1. What minimum speed should the scooterist chase the bus? Let's analyze it. Bus is moving. This is our bus, is moving at a constant speed of 10 meters per second. Okay. A scooterist wishes to overtake in 100 seconds. Bus is 1 kilometer away. So this is our scooterist. Wow. He wants to cross. I don't know what's the speed, but this distance is 1 kilometer. Okay. And he wants to catch that bus. But by the time he reaches here, the bus has gone ahead. So he will have to move further. But again, the bus has gone ahead. So we'll obviously do this problem by relative motion. So convert this problem first of all. Convert this problem. Make the bus stationary. Bus at rest. So if the bus is at rest, the scooterist will appear to move at which velocity? Come on, think about it. Bus is moving in this direction. Scooterist is moving in the same direction. Same direction. Same means equal to. Combine the symbols together, you get minus sign. Wow. So will you do 10 minus V or V minus 10? Who will be bigger? Obviously, the scooterist has to reach at some point of time, right? Scooter fellow should have more speed, or else how will he catch the bus if he is driving less than 10? So bigger minus smaller. So V minus 10 meters per second is our relative speed. Is our relative speed. What is our relative distance? It is 1 kilometer. So 1 kilometer is our relative distance. So distance relative is speed relative multiplied by time. 1 kilometer means 1000 meter. Relative is V minus 10. How much time? 100 seconds. 100 cancels. 10 is equal to V minus 10. So V is 10 plus 10. So V is 20 meters per second. From the tricks I have taught you, it becomes very, very easy. Agree or disagree, guys? Whatever tricks I have taught you, how to calculate relative speed and this formula, it's helping you. And these are all PYQs at the end of the day. I'm showing you how you can apply whatever you have learned. In 2017, Preeti reached the metro station. See, metro was not there. back in 2009. So the examples also what you see are very, very lame examples. Scooter fellow, traveling, catching a bus and all that. So India was not that much advanced that time. Now metro is there everywhere in major cities. So 2017, Preeti has gone to metro station. Amazing. And escalator is also there. Very, very high-fi. What? And oh my God, it was not working. Sorry, guys. Some problem was there. She walked the stationary escalator in time one. Escalator was not working. So she just climbed up, and you might have done this. On the other day, when the escalator is working, she will chumma stand looking at reels on the mobile as the escalator goes up. So the escalator is going up. She's just scrolling reels and she reaches on the top. But another time, what happens is she has to meet Pandu. Preeti has to meet Pandu. So escalator is going, but she wants to meet Pandu. So she will run also on that escalator in the same direction. So she will cross it in even lesser time. Do you guys agree with it? Awesome. So that is the question. That is the question, guys. So let's see how to solve this. Let's see how to solve this. Preeti reached the metro station. Okay. Let's say this is that escalator. It has some length L. Now, in the first scenario, when the escalator is not working, Preeti's speed is, let's say, U. This is Preeti's speed. Preeti's speed is U. So the time taken to cross is T1. Time is distance divided by speed. Next day, she came. She was stationary. The escalator itself was going up. The escalator itself was going up, let's say with speed V. So the time taken was T2. It is distance by speed. Now, imagine a day when both things come together. The time taken will be T, distance is still L, speed will be U plus V. Will be U plus V. Do you guys agree with it? Why it will be U plus V? Both their speeds, elevator speed plus Preeti speed will get added. Oh, awesome. So I think we need to get rid of all these things. Let's do one thing over here. U is basically L by T1. U on the top, T1 here. Similarly, over here, V will be shifted. It will become L divided by T2. So substitute it over here. Instead of V, you will put it as L divided by T2. And instead of U, you will put it as L divided by T1. Rest of the things will be as it is. Rest of the things will be as it is. Okay. So LLL will get cancelled. So 1 by T1 plus 1 by T2. Okay. Take LCM over here. So T will be basically 1 by T2 plus T1 divided by T1 T2. So I think I can just take T1 T2 on the top. So T1 T2 divided by T1 plus T2. T1 T2 by T1 plus T2, which is option number B. Got it, guys? So we have solved Preeti's problem. I hope Preeti is very happy now. Cool. Understood? Oh, clear? B for biology. Moving on to the next questions. Okay, we have come to motion in 2D now. So 1D questions are exactly like this, guys. You do not get very difficult questions in NEET physics, but we have done the PYQs and we'll do more practice once we complete the syllabus. See, I need your support for me to complete the syllabus over here on YouTube, guys. Only then I will be able to bring in my amazing collection of problems on YouTube, which are my personal problems, which I have collected from even different resources for NEET specially. And these are non-PYQ questions which will boost up your confidence. Some are from Tatva, some are from this book, some are from that book, some are my own collection, some of my modified questions, some from some amazing test series here and there. So I've collected these questions. I can do this only if you support me in completing the syllabus. If you show the attendance, if you show, sir, see, we are watching, sir. Live watching is good, sir. Sir, we are giving you so many views, sir. Sir, we are commenting, sir. We are smashing that like button, sir. Sir, so many students, sir, from South India, sir, from Northeast, sir, sir, from outside India, sir. We are watching your classes, sir. Because you are our hope, sir. Because a lot of channels are there in other languages, but for NEET, we are there for you. We are here for you to complete the syllabus, give you the quality content. So I want that show of strength, that show of support. Got it? Yep. Awesome. So let's move to relative motion in 2D. Now, the same concept, whatever we applied over here, is still applicable. Where did we go? This one. Yeah, the same slide is still applicable. There is no doubt about it. Oops. I can't copy it, guys, but the same thing is applicable. This was vectors, remember? This was nothing but vectors. So you can still use this concept, but in 2 dimension. Nothing more, nothing less. So for example, let me show you right over here, whatever we studied. V12 is V1 minus V2, A12 is A1 minus A2, S12 is S1 minus S2. But you have to use vector subtraction in 2 dimension. That's all. Vector subtraction in 2 dimension. So let me explain this, how this works over here. Say for example, our amazing Pandu now is no longer restricted to go in 1 dimension. He is going like this with velocity V1. Imagine Champa over here is let's say flying in the air like this with velocity v2 or going in some weird direction with velocity v2. If you ask me what is velocity of 1 with respect to 2, if you ask me what is the velocity of 1 with respect to 2, which is nothing but v1 minus v2, v2 is the observer, v2 is the observer. So what you will do is you have to use vector subtraction. V1 vector is as it is, V2 vector you invert it. So negative V2 vector will be like this. It's the same thing, but in the opposite direction. So this is negative V2 vector. V1 vector, just put it over here. V1 vector, just put it over here. This is V1 vector. So the resultant of them, will be over here. Resultant of them will be here. So this is V12. V12, as simple as that. Becomes so easy, guys. So what it means is that if Champa were to be assumed to be at rest, then this our Pandu who is there, over here, he will appear to go like this. He will appear to go basically like this with this relative velocity. That is what it means. Is that clear? What is the meaning of relative motion in 2 dimension? Thank you guys for all the fire. Madhumati, Srishti, Krishna, Pavneet, Savita. Thank you so much, Dinesh, Mukunda, Sony, Paul, Harborine. Oh, Harborine, you are here too. Okay, great. All right. Yes, Champa became an angel. This is the meaning of relative motion. Now, there are many applications of such a relative motion concept, and one such application is, imagine if our Champa is assumed to be at rest because she is our perspective frame of reference point of view. Our Pandu, who is over here, is moving like this. This is the relative motion. If you notice, Pandu and Champa are separated by some distance. This distance keeps changing as Pandu keeps moving, and you will notice one of such distances, which is the one over here, this is the direct perpendicular, is nothing but the shortest distance between them. The shortest distance between them, shortest distance of approach. Shortest distance of approach. So when Champa sees Pandu going, Pandu will be the closest to Champa, like, like cut Champa over here, closest. After that, Pandu is never that close. Before that, also he was far. So that's the way in which you solve those questions of closest distance of approach. Isn't it amazing? You are using this concept of motion in 2D by finding the relative motion using vector subtraction and then dropping a perpendicular on the line of the relative motion. We'll be seeing the question, don't worry. But this is how it works. You can have questions also like this, where, say for example, there is a car moving there is a car example. There is a car moving, let's say, at a speed of 10 meters per second, 10 meters per second, going like this, 10 meters per second going like this. This is making 37 degrees with our x-axis like this. And there is a bus which is moving, bus which is moving uh, with a speed of, say, for example, 20 meters per second in the positive direction of the y-axis. Question will be, find the velocity of the bus with respect to the car. This is the question. This is the question. So what you will do? You have multiple ways. You can do it geometrically, but I won't suggest that, because why do you want to use pen, paper, scale? Scale is not even allowed in the exam. So better to go by a proper mathematical way. See, if the car is going with 10 meters per second like this velocity will have two components. So the car's velocity will have two components, right? So I can split this velocity of 10, which is making an angle of 37 degrees, in two directions, one over here and the other over here. How much is this component? It is 10 cos 37. What is cos 37? Cos 37 is 4 by 5, which is nothing but then 8 meters per second. This velocity will be 10 sine 37. What is sine 37? It is basically 3 by 5. So it will be 6 meters per second, which means the velocity of the car is nothing but 8 I cap plus 6 j cap. 8 I cap plus 6 j cap. As per this given information over here, what this means is velocity of the bus is in the y direction. So it is 20 j cap. So the question asked to us is VBC, which is VB minus VC. What is VB? VB is 20 j cap. What is VC? It is nothing but 8 I cap plus 6 j cap. Subtract these two. So 20 minus 6 is 14 j cap, and this is minus 8 I cap. But usually you don't leave the answers with j first and I later on. You will always put I cap first. So it is minus 8 I cap plus 14 j cap. Is that clear? Everyone with me? This is how you solve these questions if they ask you in this manner. If they ask you what is the magnitude of the velocity, meaning the speed, so VBC modulus, which will be root of basically 8 square plus 14 square. So this would be the relative speed. This would be the relative speed in our two dimensions. This was your relative velocity in two dimensions, because both I cap and j cap are there. Cool. Understood this concept? Awesome. Awesome. Let's do a question on ship A moving west, ship B south of A moving north, time when their distance becomes the shortest. The same concept which I just explained to you before, which is useful, for solving these problems. So let's start by drawing. Let's start by drawing. Ship A is moving west and ship B 100 kilometers south of A. Okay, 100 kilometers south of A, like this, and is south of A is moving north with a speed of 10. Okay, is moving north with a speed of 10, and this ship is moving like this. That is what it means. This is basically ship number A. This is ship number B. This is going 10 kilometers per hour. Okay, 10 kilometers per hour. This is also moving with 10 kilometers per hour, and the distance of separation is basically 100 kilometers. This is what the diagram is. Okay, B is south of A is going towards the west, B is going towards the north. Perfect. So first of all, convert this problem into a simple looking problem, meaning make one person at rest and then look at the other. So let's say we try to find velocity of B with respect to A. velocity of B with respect to A will be velocity of B minus velocity of A. Velocity of B is 10 j cap. Velocity of A is minus 10 I cap. So minus minus becomes plus. So it will become 10 I cap plus 10 j cap. Do you guys agree with it? But if you ask me the magnitude of it, if you just ask me the magnitude of it, it will be 10 square plus 10 square, which is 10 root 2 kilometers per hour. Okay, so that is the vector over here. This is the magnitude, which is 10 root 2. Now, which direction is it? 10 I cap plus 10 j cap. It is east and north. So it is in the northeast direction for sure. And velocity of B with respect to A, meaning A is at rest now. A at rest, of course. And then you go 100 kilometers down over here. You will notice B going relatively like this in this particular direction. So this is how B goes. So this is the direction of the relative motion. Everybody fine till this point? Everybody fine till this point? Okay. Now, because this because this velocity was 10 I cap plus 10 j cap, which comes out to be 10 root 2 kilometers per hour. This will be definitely making 45 degrees because both the components are equal 100%. So I can quickly assume that this will be 45 degrees, number one. Secondary thing, if I drop a perpendicular to measure the shortest distance right over here, I will see this is perpendicular. This is our shortest distance. This is our shortest distance. Okay, this is 45, this is 90. Obviously, this is also going to be 45 degree. Next thing, this is 100 kilometers. So guys, what will this D be? Use cos 45 formula, you will get the answer. And you can also get this one over here. So cos 45 is adjacent by hypotenuse. Adjacent is D. Hypotenuse is 100. So D will be 100 cos 45. Cos 45 is 1 by root 2. So hence it is 100 by root 2 kilometers. That is the closest distance which they ever will be. But that is not the question, but I have just told it to you. I've just told it to you. Is that okay? Next, this was not needed for the question, I'm telling you. I'm just showing you how you would have done if this was the question. Next important thing, right over here, how much will this distance be? Let's say I call it x. I can say sine 45 sine 45 is opposite, which is x by hypotenuse, which is 100. So x will be also 100 by root 2. 100 goes on the top, sine 45 is 1 by root 2 kilometers. I am going with a speed of 10 root 2. I have to cover this much distance to come closest. So can I not say distance relative is speed relative multiplied by the time? So the distance which you have to travel is x, speed which you have to travel is v relative. This is a time to come closest. Time to come closest. X is nothing but 100 by root 2. Relative speed, how much was it? 10 root 2, and the time to come the closest. How much will it be? How much will the time to come the closest be? 0, 0 cancels. You are left with 10. Root 2 multiply with each other. So it will become basically 5. Root 2 into root 2 is 2. 10 by 2 is 5. So it will be 5 hours. So it will be basically 5 hours, which is option number 1. Is that clear, everyone? Understood how to solve these questions? Everybody with me? Pakka? This is how you solve these motion in 2D questions, especially of relative approach. Now we'll go to some special cases, which is the riverboat and rainman. Those are the special two-dimensional problems which you will usually get in your NEET syllabus. Okay, so let's go to river boat problems. So what happens in river boat questions is you'll be having some river or some stream of water in a canal, and it will be flowing with W. This is the speed of water, speed of your water flowing. Inside that, you might have a swimmer or a boat or anything. Okay, maybe this is our Pandu who is trying to swim over here. Maybe this is the velocity, this is the swimmer or basically the boat uh, with respect to the still water. This is the word which you will usually see in your question papers. With respect to still water, meaning, just think about it. Do you know when our earth spins, when our earth spins, at the pole your velocity is 0, at the equator your speed is quite large. Typically it is 0.5 kilometers per second. It's not exactly 0.5, it is slightly less than 0.5. Imagine at the equator, because the earth is rotating, your speed is almost half a kilometer per second. So imagine on the equator, on a hot sunny day, you are in a swimming pool. You might feel that you are at rest, but actually, you, with the water, with the swimming tank, the hotel, the surroundings, the trees, the mountains, the ground, are all together moving with the same speed of half a kilometer in 1 second. Imagine, zoop, 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 half kilometers in 1 second. But you don't realize it because everything is moving with the same speed because of inertia. So, if you swim in that water, if you swim in that swimming pool, in that equator, with a speed of 1 meter per second, mediocre, very laddu, very poor, very abysmal, very pathetic speed of 1 meter per second, your total speed might become, see, 0.5 kilometers is 500 meters. So, it will become 501 meters per second. You will feel, yes, I am moving at such a large speed, 501 meters per second. But that is the total velocity. Out of that, your contribution was mere one. And the most of the contribution was the water which was moving along with you. Got it? So that 1 meter per second is that velocity of the swimmer as seen by the still water. That water which is still sees 1, but actually if, as an outsider, you see the water moving and the swimmer going at 1. So you will see it at 501. Is that clear, everyone? Understood? Yep. So that is the meaning of velocity of the swimmer or the boat with respect to the still water. You will, as an observer on the bank, another Pandu who is not yet gone swimming. He's on the bank. I hope his swimming costume is fine. Yeah, okay. Yeah. So we got Pandu wearing swimming costumes before GTA 6. Awesome. Okay. This Pandu will not see the swimmer going at speed U or W. He will see the swimmer going at some resultant velocity. This is your resultant velocity with respect to the ground or basically the bank. So this velocity that is there is going to be a sum of two quantities. One is the actual swimmer speed plus the water speed. You add both of them, you will get the resultant velocity. So the water speed is basically, let's say like this, that is W. And let's say the swimmer tries to make his strokes or the motorboat is pointed in this direction. So using triangle law of vector addition or parallelogram law or any other law, you will get this as your resultant velocity. Is that absolutely clear, my dear warriors, this equation? Yep. Awesomeness. Awesomeness. Perfecto. Perfecto. Now, Now, there are few things which people by heart, which I suggest don't. Rather, remember the basic fundamental concept. Then you will never ever face issues. Here is the concept. Observe it carefully. See, you will be generally given the banks of the river. You will be probably starting from a point, and this will be the opposite point. Maybe the distance between the banks of the river might be usually given to you. Okay. And then it might be given to you that, listen, the swimmer makes his strokes like this, and the river pulls him like this, okay, with w velocity. So the resultant velocity will come out to be like this, and you end up reaching the other bank here somewhere, here somewhere, okay, something like this. This was your velocity. So realize one thing, whatever distance is there between the opposite point and the point which you reached, whatever distance is there between the opposite point and the point where you actually reached, that is usually denoted by the symbol x, which is called as the drift due to the river and the swimmer. So this is the opposite point. You drifted by this much amount. You have moved by this much amount because of the current of the river. Agree with this? This is called as the drift. And you will take some time to cross the river also. You start from here, you reach here, you will take some time to cross the river. What you should always remember is that this V, the green one, plays a crucial role. In fact, the components of it. Always try to figure out what that V is, and oops, and take that velocity, resultant velocity, and split it into two components. Split it into two components. One component here, which is basically perpendicular to the river flow, and the second component over here, which is parallel to the river flow, which is parallel to the river flow. See, that velocity can make any angle. I don't know. It could be theta, let's say, or phi, let's say. I don't know. It depends, whatever it comes out to be. Okay, so V parallel, let's say, is for example, V cos phi after finding it out, and V perpendicular is, let's say, V sine of phi. When you are crossing, when you try to cross the river, you are not even bothered about this velocity, because understand, crossing means over here. This is what crossing the river means, from one side to the other side. This is not crossing. This is not crossing. Crossing means going from one side to the other side, like this. So, always for crossing the river, remember, only consider this component of the velocity. So, whenever they ask you time taken to cross the particular river, always take the perpendicular velocity, always take the perpendicular velocity into consideration divided by the distance. So distance of the banks by relative speed perpendicular is going to give you the time to cross. Is that clear? Why it is perpendicular and not anything else? Everyone with me? Time is distance by speed. Now, when you come to the drift which is there, that drift which is there, which is x, that will only depend on this velocity, because you are going with that velocity and spending some time inside the river. So it will always be that parallel velocity multiplied by the time you spent inside the river, which is the time taken to cross, which is basically the time taken to cross always. So if you know this much, you can solve any of the problem. Most of the problems you will be able to solve. There are some few cases which we'll be dealing now, and then everything you'll be able to solve. Clear? These are the two main things. Just remember these two. You will be sorted. You will not get confused at all. Drift is this is this. And what are these components? The resultant velocities components. As simple as that. Okay, now there are two special cases. Like I said, we'll do those two special cases and then we'll go ahead. What are those two special cases? Imagine you start from the point on one bank and you want to exactly reach on the opposite side. You want to reach exactly on the opposite side. So if the swimmer swims perpendicular to the flow, because the river is going to carry him that side, you will end up getting drifted and you will reach over here. If you try to swim like this, then at an angle, the swimming strokes are in this direction, the river current is in this direction, you will end up drifting even more and you will reach somewhere here. But if you swim at the right angle, somewhere here, you are making your strokes somewhat opposite to the current, which might cancel out. And what is remaining is a component of your velocity in this perpendicular direction. Think about it. So if I know that the river current is this much, which is W, and if I know I can swim at some velocity in this particular direction at this particular angle, I will get my resultant velocity over here. So that's it. So this is basically your U. This is basically your W. This is basically your resultant velocity. The angle which you will make with the perpendicular, let's say it is theta, and the flow is over here. This is the distance which you are taking to cross. So if your resultant velocity is perpendicular to the flow, you will cross to the opposite end of the bank without any drift. This is the situation which is also called as no drift case. No drift, or basically shortest distance between the banks. Shortest distance between the banks. This is that particular special case which you should know. In such a scenario, like I said, the velocity which is resultant is going to be perpendicular to the flow of the river. Only then you will be able to do it. And if you notice in this particular triangle, if I take sine of theta, it is opposite side by hypotenuse. So opposite side being W, so it will be W by V. You will know the water speed, you will know the swimmer speed, you can find the angle using this relationship. Will you by heart this? No. What you will understand is only this concept that listen, the net velocity will be here. So swimmer will go like this, river will pull him here, resultant is here. So there will be a triangle, I can use trigonometry. Don't remember this formula. W by U, you will get confused. Was it U by W or W by U? Was it V by W or V by U? You will get confused in the exam. It's not so easy. Here it looks simple, all colored diagrams. In the notes also you will write it down properly. But when it comes to applying that in the exam, that's where the challenge is. So it's never about making beautiful notes. It's about how well you are able to apply it in the exam. So remember that. So just keep in mind, resultant velocity should be perpendicular. Only then I will be able to cross in the shortest distance, not otherwise. And if you talk about the time taken to cross, well, what will that be? The time taken to cross will be the perpendicular velocity. Well, the velocity itself is already perpendicular. You don't have to take any components. This whole velocity is perpendicular. Guys, it was distance, which is d by v perpendicular. So in this case, distance is d. V perpendicular is v itself. So it will be just v, correct? But usually v will not be given to you. V will not be given to you. So v can be written down as root of u square minus w square. That is what you can write the value of v as, correct? Using Pythagoras theorem. Using Pythagoras theorem, this will be hypotenuse square minus side square's root. That's how you will write it. Clear this point? Yep. Will you remember this? Obviously not. Never. Okay, I've just told you how to solve it. The only thing you will remember is this. This is the one which will help you solve the problem. This triangle, you know how to draw it thanks to this particular statement which we made over here. This was our main equation, if you noticed. This was our main equation. Okay. Now, moving to the next scenario. You want to cross the river in the shortest time possible. Maybe the water is very cold. You cannot spend a lot of time inside the river. You want to spend least amount of time inside the river. Even if you encounter some drift, it's okay as long as I reach the other bank. Maybe there are some reptiles, there are crocodiles, and you want to spend very little time inside the river. How will you swim? The more time you spend, the chances of attack are more. The more time you spend, if the water is cold, you might get hypothermia. So how will you swim inside this river is the question. Come on, think and tell me. You will use your maximum velocity to cross the river. What is the direction of cross? Cross is this. If you bend your velocity here, your resultant velocity in this direction will have a component, which means lesser velocity is used to cross the river. But if you use the complete velocity here, this resultant velocity, sorry, whatever it is, resultant velocity will be making as much component as possible in this particular direction. So you will try to swim such that maximum velocity as much as possible is over here. See, river is not contributing here. To cross, it is perpendicular. Water velocity is perpendicular. So you will keep u perpendicular so that you are able to cross in the least amount of time. So that is the reason why you will see that your swimming strokes will be here. The water flow will be here and your resultant will be here like this, but you will now end up drifting. That's okay. It is acceptable, not an issue at all. I am aligned with it. So there will be 100% some amount of drift over here between these 2 points. Is that clear? Now in this case, if you ask me what is the time taken to cross, if you ask me what is the time taken to cross the river, which is distance by v perpendicular, notice one very interesting thing over here. This v perpendicular, v's perpendicular component, this is v, this will be v perpendicular component, will be exactly u only, will be u only. Think about it, correct? Because this is just simply put w. So v perpendicular is u, so you will just put over here u. Will you by heart this? No. You will understand it. Okay, this triangle is formed. The perpendicular velocity is u only because water was not contributing at all. That's it. That's the time taken to cross. If you ask me what is the drift, if you ask me what is the drift which is encountered, it is always the parallel velocity multiplied by the time taken to cross. Multiplied by the time taken to cross. Time taken to cross is just the same thing. What is this parallel velocity, guys? Guys, just check this out. This parallel component of the velocity is exactly w, nothing else. So this parallel velocity will be nothing but w itself, will be w itself. That's all. So that is how you will get the answer. Is that clear? Everyone understood these two special cases? Very nice. So you will be able to solve now any questions on this. Let's have a look at some questions. Boat covers certain distance between two spots in a river taking T1 hours going downstream and T2 hours going upstream. What time will it be taken by the boat to cover the same distance in still water? Upstream and downstream. This is not even a 2D question. This is a 1D question. So let's have a look at it. Boat covers certain distance between two spots of a river. These are the two spots of the river. Let's say the distance is L. Uh, Takes time T1 going downstream and T2 going upstream. Okay. So if you are going down the stream, then your speed will be u plus w. Downstream, u plus w, because down the stream means in the direction of the flow. The speed of the river and your speed will add, it will contribute, and you will see the net speed will be more. So T1 will be basically distance. What is the distance? L divided by speed. So distance by your speed. That's all I have done. If you go the other way around, the same distance, your speed will be u minus w. So that T2 for going upstream will be the same distance upon u minus w. If you have to cover the same distance in still water, what is the meaning of still water? W is not there. So that time will be that distance by only the boat speed. So what do I have to do now? I need to get rid of u and basically w. If I can find that out, my job is done. So I have two equations, guys. You just have to solve it to get the answer. How will you do it? Think about it. How will you do it? Think about it. So from here, what will you get? From here, you'll get u plus w is basically L by u, sorry, L by T1, L by T1. And from here, you will get u minus w is basically L by T2. I'll get rid of w by adding both of them. I'll get rid of both of them by adding both of them. So if I add both of them, I'll get basically u plus u, w has got cancelled, sorry, u plus u, w got cancelled. I will get L by T1 plus L by T2. So basically, I'll get 2u is equal to this. So L common divided by 2, 1 by T1 plus 1 by T2. Understood? 2u. U plus u is 2u. Bring that 2 down. L I took common. So 1 by T1 plus 1 by T2. So it will become L by 2. Take LCM. It will become T1 plus T2 by T1 T2. So that is what u will be. Substitute it over here. That's all. So it will be L divided by u. U is basically L by 2. What is it? T1 plus T2 divided by T1 T2. Okay, LL cancels. 2 T1 T2 goes on the top. 2 T1 T2 goes on the top, and T1 plus T2 remains over here. So 2 T1 T2 by T1 plus T2, which is the option C. Got it, guys? Understood how to solve the question? Yeah, simple mathematical manipulation. C for Captain Shreyas. Yes, that's correct, my dear warriors. Awesomeness. Okay, moving on to the next question on your screen. A boat crosses the river with a velocity of 8, resultant velocity is 10, then the velocity of the water is how much? Boat crosses with 8, resultant velocity is 10, then the velocity of the river water is how much? So think about it. The boat is crossing with a speed of 8. The water velocity is unknown. The resultant velocity is 10. This was asked in PMT 2001. Guys, isn't this Pythagoras theorem? Basically, 10 square is basically 8 square plus w square. So w square is 100 minus 64, which is 36. So w will be 6. So that is the answer, which is 6 kilometers per hour. Straightforward. How many of you got it? B for biology. Very good. Awesomeness. Awesomeness. Let's move on to the next question on your screen. The speed of a swimmer in still water is 20, speed of the river is 10 and is flowing due east. He's standing on the south, goes to the north via the shortest distance. What angle should he make? Guys, shortest distance question. Let's do this. Shortest distance question. So these are the banks. He wants to cross the river with the shortest distance. So his strokes will be somewhere over here. The speed is 20. So U is basically 20. The river will pull him like this with what speed? 10. So the resultant velocity will be like this. What did I tell you? Never by heart anything. Just remember the logic. That is his resultant velocity. So the question is basically, what angle does he make? What angle does he make with the river? Okay. Theta. I can use sine theta. Sine theta is opposite by hypotenuse, which means it is half. So theta is basically 30 degrees. But keep in mind the directions now. Remember, this is your east direction. This was your west direction. This was your south direction. And this was your north direction. So 30 degrees he is making with what? North. 30 degrees he is making with north towards west. 30 degrees with north towards west. Yes. 30 degrees west, 30 degrees west of north. Option B. I know time is not asked, but example time was asked. Example. So the time taken to cross, if it was asked, time taken to cross, if it was asked, what will you do? You will need this velocity, and how will you find this velocity? This is 20, this is 10. So 20 square is 10 square plus v square. So v square is 400 minus 100, which is 300. So basically v will be 10 root 3. So time to cross will be distance. What is the distance? It's not given. Assume, 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 assume distance is something. Let's say, I don't know, maybe 10 root, sorry, something like this. Let's say it is 30 meters, example. So it is distance by your perpendicular speed. So distance is basically 30 meters. Perpendicular speed is 10 root 3. So hence 30 by 10 is 3. So 3 by root 3, which will become root 3 seconds or whatever, root 3, yeah, root 3 seconds. That's how you will do it. Is that clear, everyone? If it was asked. I know it is not asked here, but you will. I'm doing this just so that if such a question comes, because you will see if you analyze previous year papers, they just twist the same questions here and there and they ask you some different thing. Same NCERT questions twisted again ask. So if they ask you time, next year they will ask you, drift. If they ask you drift, next year they'll ask you angle. So it's the same thing which they keep playing around. If the same question was modified, imagine if the same question was modified for shortest time, example, shortest time, then the same question, then what will happen? Just think about it. Your velocity of how much? Your velocity of 20 will be directed like this. River velocity was how much? It was 10. So it would be directed like this. And your resultant velocity would be over here. That resultant velocity will be root of 20 square plus 10 square, which is 400 plus 100, which is 500, which is basically 10 root 5 meters per second. That would be the resultant velocity. If you ask me the time taken to cross, which is distance by v perpendicular. Remember, distance we took as 30 meters. Perpendicular speed is basically 20 only. So it will be 3 by 2, which is basically 1.5 seconds. Which is basically 1.5 seconds. If they ask me drift, it is parallel velocity into the time taken to cross. What is the parallel velocity? The parallel velocity is exactly 10. It is exactly 10 and time taken is 1.5. So it will be basically 15 meters. That's how you solve the problem. Got it? Are you now confident about riverboat problems now? Shall we go to the last kind of question? My dear warriors, which is the Rain Man question. Rain Man problems. Everybody full of josh, full of energy. Smash the like button. Call your friends. Don't lose focus. Don't lose your concentration, because our target is very, very big, 700 plus. Our target is to become our top-notch medical, professional in the best of the best colleges. Remember that. Awesome. Great. Moving on now to Rain Man problems. How will I hold the umbrella? So usually what happens is whenever it rains, if somebody has a bag, usually you just carry the bag like this because you want to prevent yourself from getting wet. But if the rain is coming from that direction, you'll obviously hold it like this because you want to prevent yourself from getting wet. How is this? Like this. The rain is coming from here, I'll hold it like this. If I'm standing, but imagine I'm running. Now, even if the rain was falling like this originally, because I'm running, the rain will fall on my face. So I will not hold the umbrella like this. I will hold it like this. Agree or not? I'm running. So I'll hold the umbrella or that whatever the thing is at an angle. So the questions are exactly that, at what direction, in what way will you hold, the umbrella or your protection, so that you do not get wet or you get least wet, because there is relative motion, especially when you are running. Is that clear, everyone? So the logic used for that is as follows. Very, very simple. What matters to me is how the rain appears for me, not for the person standing outside, for me. So what is important is velocity of the rain with respect to that man or that person who is running, walking, stationary, whatever he might be doing, but for him. So V12 was V1 minus V2. So VRM will be, simply put, velocity of the rain minus velocity of the man. Velocity of the rain minus velocity of the man. As simple as that. This is actually your governing equation. If you know this, you can solve any problem. It's nothing but vector subtraction. If you understand it is just vector subtraction, there is no other formula. A lot of people have seen, I don't know how any teacher can give any formula in this, because then you are destroying the entire creativity, or just destroying that subject by giving a formula. It is just this, nothing more, nothing less. So say for example, our Pandu is running like this. This is the velocity of the man. And let's say, the rain, let's say the rain is coming like this. This is the velocity of the rain. And I want to know, how am I going to hold the umbrella? How am I going to hold the umbrella? Just use this equation VR minus VM. So as you can see, first thing that you need to do is take the VR vector. So fair enough. This is our VR vector. Let's say it is like this. Okay. So this is velocity of the rain vector. But don't take Vm. You will take negative Vm. This is vector subtraction. Don't forget that. This is vector subtraction, guys. So negative Vm could be like this. Negative Vm could be like this. Yep. Triangle law of vector addition. That's all. Triangle law of vector addition. So complete that triangle starting from the start to the end. This is basically your VRM. This is basically your VRM, which means this particular Pandu will take a stick of the umbrella in the exact same direction like this. So his umbrella or that protection will be like this. And our Pandu will be very, very happy. Like you can see, he was not that happy over here while he's running. And she will find the rain in this direction. This is relative to him. It's very awkward, very non-intuitive, but it is true. Even though the rain was coming from behind him, because he was running so fast, the rain appears to fall on his face. That is crazy. You're moving so fast. So this is how you solve those questions. This is the direction in which the stick of the umbrella is being held so that he gets least wet. Is that clear, everyone? Amazing, isn't it? Rain was coming from behind, but in this scenario, you ended up holding the umbrella in the front, even though the rain is coming from behind, because for you, you are moving so fast, the rain appears to fall on your face. What an amazing thing. So let's solve some questions based out of this. A man moving with 5 meters per second observes the rain falling down at 10. Speed and direction of the rain with respect to the ground. Interesting. Man already moving with 5 observes the rain falling at the rate of 10. Okay, let's think about it. The person is moving maybe like this, with a speed of 5 meters per second. This is velocity of the man. Okay, appears to him, that means the resultant velocity Vrm vector is 10 meters per second. Question is, what is Vr vector, the rain velocity? Now we all know that Vr minus Vm is Vr. So first of all, let me take the negative vector of Vm. So this would be negative Vm. This would be negative Vm, but still it will be magnitude wise 5 meters per second. Now just focus your attention only on these two vectors. Forget this now because this is of no use. Minus Vm vector is our priority. Somehow construct a triangle whose resultant is this Vrm. One of the vectors is Vm negative and other vector is Vr. Just try to think, how will you get this as the resultant? Just think, how will you get Vrm as the resultant? And you want negative Vm also. I think negative Vm, let's say if I put it over here, I have a feeling I will put Vr vector over here. Just check this out. Does this triangle make sense to you? Vr plus negative Vm is Vrm. What a brilliant way of constructing. So this is Vrm, which is having a side length of 10. This is your negative Vm, which is having a side length of 5. So naturally, this is your Vr vector. Clear? So how do you find Vr? Guys, Vr will be nothing but use Pythagoras, 10 square plus 5 square, which is 100 plus 25, which is 125. 125 is 25 into 5, so it will become 5 root 5. So it will become 5 root 5 meters per second is the rain velocity. Yes, very good, Harparai. Awesome. What about the angle which it makes? Theta. So I can use tan theta. Tan theta is opposite by adjacent, which is 5 by 10, which is 1 by 2. So theta is tan inverse 1 by 2 with with the vertical direction. You can't find it beyond this. Just leave it like that. Options also will be in that format. Yeah, 5 root 5 and tan inverse 1 by 2. Tell me, which formula did I use? Did I use any formula? No formula I used. What I remembered was only this equation. Vrm is Vr minus Vm. It is vector subtraction. That's all I know. After this, I just used, whatever knowledge I have of geometry, basic common sense. Okay, I have to use minus Vm, vector subtraction. You arranged and made a beautiful triangle. You use Pythagoras, trigonometry, and you got the answer. So there is no formula as such which will help you guys. That is what many people fail to understand. And I've seen many teachers giving formula which is completely wrong. I mean, you're fooling that student. Okay, because that student will always get confused, or when a twisted question comes, will not be able to solve in the exam. Don't do that. Okay, next question. Rain is falling vertically down with some speed. Wind starts blowing. Okay, after some time with some speed, east to west direction, the direction in which a boy standing at the place should hold his umbrella. Boy is standing. Rain is moved because of the wind. Okay, rain was falling down. At what speed? 35 meters per second. So this is how the rain was falling down. 35 meters per second. The wind starts blowing with a speed of 12 in east to west direction. Okay, so maybe I'll just put this over here. This is Vr, which is 35 meters per second. Wind starts blowing. Wind will blow here. So this is the velocity of the wind. What is the speed? 12 meters per second. So because of which the rain will have a resultant velocity. This is our resultant velocity. Yes, like this. The direction in which a boy standing should hold the umbrella, because then if you hold the stick of the umbrella like this, you will be safe because you will see the rain coming towards you in this direction because the wind has added some velocity to the rain. That's all. So question will be, with what angle will you hold the umbrella? So this is basically your theta. You can clearly see tan theta is opposite by adjacent. So theta is tan inverse of 12 by your 35. Tan inverse of 12 by 35 with respect to the rain. Tan inverse of 12 by 35 with respect to the rain. Is that clear? Yes, it is option number C. Perfect. Simple vector concept. Tell me which formula I have used. Nothing. That's what I've been telling you. There are places where you don't need formulas. Okay. You just need to know the concept, and concept you have to learn. You cannot say, sir, it's difficult, sir. Please tell me formula, sir. I will by heart all the cases. All the best. It will be very difficult for you to crack NEET because you should know the concept. Man standing on the road holds the umbrella at 30 degrees with the vertical to keep the rain away. Rain, rain, go away. Okay, he throws the umbrella, wow, and starts running. Man, I like this person. Cool. He did not, he did not, hold the umbrella. He ran in the rain. Very good. At a speed of 10. He finds the raindrop are hitting his head vertically. Okay, fine. The speed of the raindrops with respect to the road will be how much? Okay, let's do this. Interesting question, isn't it? Again, like I said, no formula needed, just knowledge of vectors. A man standing on the road holds his umbrella at 30 degrees with the vertical to keep the rain away, meaning the actual velocity of the rain is like this, and it is making 30 degrees with the vertical. This is basically your VR vector. He throws the umbrella and starts running at 10. Okay, he starts running at 10 and he finds that the raindrops are hitting his head vertically. That means if the person starts running, the rain's velocity with respect to man is vertically down like this. I have to think about our vector subtraction. VRM is nothing but VR vector plus our negative VM vector plus our negative VM vector. This is the governing equation. How do I get this as the resultant? By keeping this vector and this vector. Let's think about it. Guys, I think there is only one possibility that I can think of. Take this VR vector here. Is that okay? Take this VR vector over here. I will add to it another vector to get VRM. I want VRM, right? So VRM is over here. VRM is over here. Perfect. The only way I can do that is by placing this negative VM vector here. Is by placing this negative VM vector over here. Is that making sense to all of you? VR plus negative VM is VRM. This is the resultant using triangle law. That's it. Your job is done. Our job is done, guys. Yep. So the question is, he finds the raindrops are hitting and the person speed is also given to us. What is the person speed? This speed is given how much? How much? 10 kilometers per hour. Also, one more thing given to us. This is 30 degrees. Question is the speed of the raindrops with respect to the road. That means VR is asked. Guys, use opposite and hypotenuse. So use sine of 30. Sine of 30 is opposite, which is 10, by hypotenuse, which is VR. So VR will be 10 by sine 30. What is sine 30? It is basically half. So that half 2 will go on the top. So it will become basically 20. So that's the answer. I just use basic trigonometry, nothing else. So 20 kilometers per hour. Isn't it fascinating? Understood, guys? Are you now convinced? Are you now getting that confidence in these questions? Yes or no? Tell me. Okay, so we have a homework question. We have reached the end of the class. I want everybody who has attended this class live or recorded. And I will know that, okay, at least you have watched the class recorded. Maybe you had a class or whatever coaching, and then you attend this class. Even after 1 month, it's okay, but put the answer in the comment section. The answers will be in the form of PDF in our treasure box as well. Okay, so just check that out and let me show it to you where it is. As you're watching this class over here, let me go down. Okay, and go down over here. You will see, where is our treasure box here? Where did our treasure box go? Treasure box. Yo, somewhere it went off. Okay, I'll get that link added, guys. Treasure box link. But On the Telegram channel, I'll be sharing it directly. So this is our Telegram channel link. Okay, so this Telegram channel, you join it so that you will be able to get PDF also. Okay, on that I'll just make sure that treasure box links also get updated. And one more thing which you should know, that right now all our products are on sale. Like for example, the DNA batch, because of the Republic Day offer, it's for just 999 rupees, which was otherwise 5000 rupees. This is only for a few days till August 16th. After that, again, we'll be coming back to normal price and it will never ever come down again. Even the combination DNA plus NCRT test series plus Tatva module. So these test series are courier to you. This is pen and paper module. You can see it is for 5,999 rupees. That's very, very good price. Plus the Tatva hard copy, which is our coaching module, is given to you at your place. If you just are interested in Tatva module also, it's available at a very good discounted rate. Like you can see 3,777 over here. And there are many more products which you can go through on our store. So a lot of people might want, something else as well. So guys, the links are updated over here, be it Tatva modules, previous year books, anything, your school books, VBuddy, merchandise, any of the NEET PYQ materials, guest papers, all the things are on fire sale right now. So make the best use of this right now is what I would say. This will only go until 16th August. Keep that in mind. Okay. So God bless you all, and post the answer of the homework in the comments after the video is over. Okay. I've shown you that question. Post it in the comments. Bye bye. Captain Shreyas signing off. Hasta la vista.